Again, today we're going to go over trig functions and trying to figure out how to determine our rafter size as we go through. I'm going to ask you guys first, who recalls what our trig functions are? So, we got second to it. So what are our trig functions? Go ahead, Eric.
You have sine, cosine, and tangent.
Alright, so we have sine of theta, cosine of theta, tangent of theta. And what do they equal? As that?
Sine is opposite over the hypotenuse.
Opposite over the hypotenuse. Cosine? Anybody recall? Adam?
Adjacent over the hypotenuse.
Adjacent over the hypotenuse. And that leaves us with the tangent, which is the
Opposite over the adjacent.
opposite of the adjacent. All right, so one of the nice things about industrial tech is this is where you guys get to apply all of that stuff that you're learning in your math class. So, and we're going to apply it, of course, to our rafters. So we've talked about pitch. Who can tell me and give me a good idea of what pitch is? It's the slope, right?
So right
Pitch
over
is the slope, which basically is the same as a rise over the run. Rise over run. And in terms of roofing, so how do we give that? So what are some examples of our pitches that we talk about? Sydney, what's one example? A 412. All right. So what does 412 mean?
Every 4 inches it goes up, it
Okay.
runs 12 inches.
Yep, so we got the run here of 12 inches, and we've got the rise of 4 inches. All right. Here is the other side of our triangle. So, what side would this be? The longest line is always the hypotenuse, right? So this is the hypotenuse. And let's say this is our angle of theta. Which trig function do we want to use to determine this?
A squared plus B squared is C squared.
All right, we could, so we could go a squared plus b squared equals c squared. And that would say 4 squared plus 12 squared equals c squared. This is 16 plus 144 equals c squared. We got, what's 144, 150, 160 equals c squared, right? And then we take the square root of both equals c. What does c equal?
12.65.
12.65. All right, so that's one way, 12.65. But I want you to actually apply and use the trig formula here. So which trig formula could we use? Adam? The tangent. So tangent of theta, we don't know theta yet, so equals, which one is our opposite? So you got two choices here. 12 over 4 or 4 over 12. Which side is opposite of our theta angle and which one is adjacent to our theta angle? Okay. So we got one side here and one side here. This is a key concept to always remember. Griff, what do you think? Is this opposite that angle, or is this adjacent to that angle? No, are you sure about that? Okay. Notice, this line here is right next to the angle. So this is the adjacent. Okay. This is the line opposite. So you go opposite, it's the one that's across from it. So the correct formula here is 4 over 12. Now, Griff, if we wanted to find beta angle right here, now which side is the opposite? We're now looking at this angle right here. This is theta, this is what we refer to as beta. So, yeah, in this case, the opposite side is 12 and the adjacent side is 4. So if you kind of keep that in mind, it's like which one of these angles or which one of these lines is right next to the angle, which one is across from the angle. So you'll get it right. Now, that leaves us tangent of theta equals, what's 4 divided by 12? 0.33 repeating. So, how do we find theta? We take the inverse tan. So, alright, so if you are using a Texas Instrument, so key and sequence for Texas Instrument, I'll show you that. If you're a Casio fan, I'm sorry, I apologize, I'm a Texas Instrument person. So key and sequence with Casios is different than Texas Instruments. So basically all I have to do, hit 0.33, and then that second function, so you should have a second function, hit second and tan. And what do you get in here? Connor, what do you get for?
Mine's in there. So I think I have to, on the one I have to do the tan first and then the 0.33.
Okay.
So I
So
got 18.26.
18.26. What is that? What does that really mean? What's our unit here? You got to do a couple of things. First off, you got to make sure you're hitting the inverse tan. And Adam, what do you have to be in as far as function? Degrees. So you got to be in degrees. So Connor, what's our unit here? 'Cause we're in what, inches up here? What's our unit down here when we do this? What are we really finding here? Okay. Griff?
Yeah.
So our units here are inches. But what's our unit here? What are we actually finding?
Degrees.
Degrees, yeah. This is our degree. So that means that this is 18.26 degrees. So now, if you think about it then, and going back to how it's kind of applied to our pitch, so if we have a 12-12 pitch, what's the degree of theta on a 12-12 pitch? So remember, this side is equal to that side now because we're rising 12 and running 12. Adam, it's a 45-degree angle. Okay? So basically, as we go, different pitches are going to be narrower on up. So this is kind of a appropriate way to kind of talk about the math, and we're going to kind of consider this when we start to lay out these lines. However, and you, again, I don't want you to get confused because sometimes you'll see this symbol on a drawing when we start to look at drawings that might be up like that to kind of show you the slope. All right, you remember your geometry and your complementary, supplementary, all those different adjacent. It's the same thing, it's just reversed. But here's two ways. So we can use, what do we call this, Bobby? Pythagorean theorem to find the length of the line. So, and that's going to be this length right here. We can also use trigonometry to find our degree angle. So, as needed there as well. Now, we got to watch it though, because just because we found the length of that line, we're going gonna be adding more to it, because if you recall what we talked about with the rafters, so the rafter actually goes up, and you got more dimensions to that rafter than just that specific line there. So we've got multiple dimensions, and we're gonna have to kind of use some things here as we go.